The formula for the quadratic number pattern is given by Tn equals an squared plus bn plus c. All right. So if you want to find T1, you need to put n equal to 1. So if you do that, if I put n equal to 1, I will end up with a plus b plus c. Are you happy with that one? I'm just putting n equal to 1. So I get that. But if I put n equal to 2, in order to get the second term, so now n is equal to 2, so this will be 2 squared, and that will be 2b. So this becomes 4a, right? 4a plus 2b plus c. If I want T3, I need to put n equal to 3. 3 squared is 9. So you see why this is 9a, and that one is 3b, and that one is c. Let's do the last one, T4. I put n equal to 4. That will give us 16a plus 4b plus c. So these are the first 4 terms of a quadratic number pattern. Let me write them like this. So we've got a plus b plus c. That is T1. Then T2 is 4a plus 2b plus c. And then the third term is 9a plus 3b plus c. And the fourth term is 16a plus 4b plus c. Now let's work out what we call the first differences. In other words, what is T2 subtract T1? So it's 4a minus a, that will give us 3a. And what is 2b subtract b? That's a b, right? C minus c will give us 0. So we end up with 3a plus b. And then what is T3 minus T2? So it's this minus that, which is 5a. 3b subtract 2b will give us b. The c's will disappear. Okay, and then what is T4 minus T3? 7a plus b. All right, so these are called the first differences. Do you see that the first differences are not the same? So the first differences are not equal. 3a plus b is not equal to 5a plus b, is not equal to 7a plus b. Otherwise, if these were equal, then this was going to be a linear pattern, but it's quadratic. So let's go on and look for what we call the second differences. So for the second differences, what is 5a plus b subtract 3a plus b?
2a.
2a, right? And what is 7a plus b subtract 5a plus b? Again, that is 2a. So you see that the second differences are equal. And then the magic numbers, are these numbers here. And that is all you need to remember, because you don't want to start from the beginning all the time you meet a question like this. You just need to remember that the number there has a value of a plus b plus c. Whatever number you get here has a value of 3a plus b. And whatever number is there has a value of 2a. All right. So let's make use of this now and answer a question. Right. What is 3 squared plus 2? What about 4 squared plus 2? Am I even right? What is 4 squared plus 2?
18.
4 squared plus 2 is? 18. 18. Okay. 5 squared plus 2? 5 squared plus 2? 20? 27. 6 squared plus 2? 38. Okay, let's see whether this works. Let's look for Tn for this particular sequence. So first of all, work out your first differences. 18 minus 11? 7. 27 minus 18? 9. 38 minus 27? 11. So is this a linear pattern?
No.
No, it's not linear. Why is it not linear?
There's no first one.
Because the first differences are not constant, right? So no. Then go on to work out your second differences. That's a 2. And so is this a quadratic sequence?
Correct.
And why is this a quadratic sequence? Because there is a constant second difference. Then you take note of your magic numbers. Take note of those magic numbers. This one is always given equal to 2a, and that one is always equal to 3a plus b, and that one is equal to a plus b plus c. All right. And then you start solving for a, b, and c, starting from the bottom. So you work upwards like this. It will be easy that way. So let's do that. So from down here, it says 2a is equal to 2. Therefore, a is equal to 1. So now we know that a is 1. Then you move on, you get 3a plus b. What is 3a plus b equal to?
7.
This is equal to 7. But we know a. So we know that a is 1. Therefore, what is b?
4.
Is it 4?
Yes, sir.
Right. Then you move on to the next one. A plus b plus c. What is a plus b plus c equal to? 11. But we know a is 1, b is 4, so we can find c. So what is c equal to? Is it 6? Okay, so c is equal to 6. Therefore, what is tn equal to?
Just substitute all those values.
We now substitute. Remember the formula is given by an squared plus bn plus c. What is a? So I'm saying it's an squared plus bn plus c. But now we know what a is, so it's 1. Can I leave it out? And just write n squared. Plus bn, what is b? 4. Sorry, 4b. It's 4n. Plus 6. So this is the general term. Okay. And we are done. You get 5 marks for that.
Really?
Yes.
Then where is the sixth mark?
The sixth mark could be the first question. A simple question like, is this a quadratic pattern or not?
Okay.
Prove that this is a quadratic sequence or not.
Okay.
Or it could be write down the next 2 terms of the number pattern.
Oh. I know.
Okay, so do you think, without working out Tn, do you think you know how to work out the next 2 terms?
No.
So tell me, suppose your sequence is 11, 18, 27, 38. And I want you to write down the next 2 terms. And that could be the first question. If I bring that as the first question, I know that some of you will want to first of all work out Tn. Then after working out Tn, you then substitute and so on. But is that necessary?
To me.
I think, who has a strategy for finding the next terms? Yes. You will definitely get your first differences first. That is the first thing to do. What is your first difference? What is the difference here?
7.
7 and then
9.
9 and then
11.
11. So what is 11 plus 7?
18.
18. Right? What is 18 plus 9?
Oh,
27.
That's what I did
Makes
first.
so much
And
sense.
what is 27 plus 11?
I did that first.
A number, 38.
27 plus 11, 38, right? So to get the next one, it's 38 plus
13.
13, which will give you 51. Then the next one will be 51 plus
That is so
15, which will give you
Why am I young?
66, and you are done. That is shorter than you, first of all, working out the general term. Can you describe what is happening? How are we actually getting these terms?
Magic.
First of all, we're adding we're adding a 7 to the first number to get the second number, and then we're adding a 9 to get the next one, and we continue adding 2 more than what we added earlier on in order to get the next term. So you can actually write a paragraph explaining how you get these things.
So